Bismillah ar-Rahman ar-Rahim. Good afternoon, everyone. Today, our lecture will explain to us the space charge width. This topic belongs to chapter 7 at the conductive course. Here, we will explain the space charge width at the thermal equilibrium, and we can determine this distance by depending on two important equations. Actually, this equation is 7.18 and 7.27 because totally 100% will dependent on all these equations to solve the next examples, because the next lecture will be, we will try to solve all the examples has relation with this topic. Let's start today with our lecture from this equation. The width in the N region dot donor concentration equal the width at the P region dot acceptor concentrations. From this equation, we can know the last equation to width in N region, because will be width in P region dot acceptor concentration divided on donor concentration, and this equation from the source, its number is 7.27. Let's keep going. Here we will use the belt barrier potential. By using belt barrier potential equation, we can simplify this equation and try to find the last equation to width in N region and width in P region. Let's keep going and see that together. Now let's start to determine the width in P region. Like I said before, we will we will use the equation 7.26. The belt barrier equation equal electron divided on 2 permittivity between 2 bracket donor concentration, width in N region square plus acceptor concentration dot X width in P region square. Like I said before, from 7.17, we have this result, width in N region equal width in P region, acceptor concentration divided on donor concentration. We will put equation 7.27 here and calculate this equation again. And by this way, we have a target, we have goal. We will reach it to simplify appropriate equation to Xn, and by use it, we will find the last equation to width in P region. Here, like I said before, we put the result of width in N region here and keep going. Here, by this situation, we have just one unknown. That's for what we need to calculate this unknown equation. Here, electron charge, acceptor concentration square divided on 2 permittivity dot width in P region square between 2 brackets, 1 divided on donor concentration plus 1 divided on acceptor concentration. Here, belt barrier potential equal this equation, electron concentration Na square divided on 2 permittivity to the dot the width in P region square. And by this situation, by this equation, we will try to calculate this result to width in P region dot this bracket. Here, by use the root 2 XP, the width in P region, this very important equation to us, equal, after modify all that, here we will use the situation, we will take donor concentration and acceptor concentration outside, like common vectors, outside the bracket, and after that, we can delete the square to acceptor concentration and delete up the acceptor concentration to be the general equation to width and P region, like that, to permittivity built barrier potential divided on electron charge between two brackets, donor concentration divided on acceptor concentration, dot 1 divided on acceptor concentration plus donor concentration, all these brackets to root 2. This equation, like our source will be 7.29. Like we know here, XP is the width of the depletion region extended into the P region for the case, but here we're dealing with important condition. This condition is we're dealing with zero applied voltage between P side and N side. Let's keep going to find the result of the width in the N region. Like we said before, we benefit from equation 7.17. And by this way, we found the result, the last equation of Xn here equal the width of P region, acceptor concentration divided on donor concentration, and this equation was 7.27. We know the result of the equation of the width at P region, it was 7.29. We will put this result here and calculate equation 7.27 again. Like we see here, we deleted the square from acceptor concentration and from donor concentration to be this equation, the same equation, not has similarity with the width in P region, and I will explain that next at the next slide. The width in N region equal to permittivity bolt barrier potential divided on electron charge dot NA acceptor concentration divided on donor concentration. Like we noted here, XP has the same result, but width at the P region, his result was donor concentration divided on acceptor concentration. This important note, because by using this note, we can keep this equation easily in our mind, okay? Though this bracket, all these bigger brackets to root 2. This equation is like our source, 7.28. That's mean equation and 7.28 and 29 similar from 7.29 similar with 7.29 by all the elements except this bracket here and the bracket here. Okay. And we're dealing with the same condition with zero applied voltage. The total depletion or total space charge width is like equation in 713. We will calculate, we will put plus between these two results. These results is the depletion in N region plus the depletion at P region. We know the results of these two equations, 7.28, 7.29. Just we will put plus between them and calculate all this equation again. Here we're dealing with two sides. All these two sides have element vectors, common vectors, sorry. We can take these common vectors outside the bracket and calculate all that again. To simplify all that, I just take this bracket in another side to calculate it alone. Okay, like we're seeing here, we will delete some element to simplify it. The last result is acceptor concentration plus donor concentration divided on donor concentration, acceptor concentration dot this bracket Na plus Nd. Here, to make this equation like our source, we can see near from this result by ignore this bracket, will be acceptor concentration donor plus donor concentration divided on Nd dot Na. Just we will put this last result here and we will calculate all this equation again. By this way, the total Widith at thermal equilibrium at PN junction equal to permittivity volt barrier potential divided on electron charge between two brackets, acceptor concentration, donor concentration divided on donor concentration dots, acceptor concentration. And this equation will be the 7.31 like our source. That's it. Today our lecture is finished, is done. The next lecture, we will try together to solve all the examples have relation with our topic. Thank you about your patience, your attention.